At the farthest edge of our solar system, where sunlight barely touches frozen clouds and gravity seems to forget its own rules, one planet has quietly defied every expectation: Neptune. For over a century, it has been the distant sentinel, a cold gas giant cloaked in mystery, known only through math, a fleeting flyby, and the occasional telescope whisper. But now, the James Webb Space Telescope, the most powerful eye humanity has ever turned toward the stars, has delivered a revelation so unsettling that it has shaken even the most seasoned scientists. This wasn't just an update. It wasn't an improvement in clarity. It was a warning, a cosmic red flag that what we thought we knew about Neptune was wildly, dangerously wrong. Neil deGrasse Tyson, in a packed auditorium and under the glare of a global live stream, dropped the revelation with the gravitas of a scientist confronting the unknown. Neptune's internal structure, its magnetic field, and even the very laws governing its orbit no longer align with Newtonian predictions. Something is off. And it's not just strange, it's terrifying. Because if Neptune, a planet we thought we understood, is hiding a secret so radical it rewrites planetary science, then what else is out there lurking beneath the veil of our assumptions? 4 years, astronomers tracked Neptune's orbit with robotic precision. Everything aligned until it didn't. New Webb data combined with Earth-based interferometric arrays revealed anomalies. Neptune's trajectory began to show subtle deviations from Newton's laws. Its path through space, once predictable, now whispered of a deeper, invisible influence. At first, they blamed the instruments. Then they blamed the software. But the truth was far more chilling. Neptune was moving in ways that defied gravitational logic, as if it were responding to an unseen force, or worse, harboring one within. And this was only the beginning. When Neil deGrasse Tyson took the stage to explain what the James Webb had uncovered, the room fell into a silence, not of awe, but of alarm. Because beneath Neptune's familiar blue swirl lies an internal structure unlike any other planet we've ever studied, layers that don't obey the laws of density or pressure, thermal zones that generate heat without any solar input. In short, Neptune behaves like a machine with a broken blueprint, or one running on a set of physics we haven't discovered yet. Neptune's magnetic field has always been odd, tilted, lopsided, and misaligned from the planetary core. But now, it's shifting, not in geological time, but in human time. Sections of the field appear to fragment and reassemble in dynamic cycles. The James Webb and supporting observatories picked up pulses, magnetic waves surging and collapsing with patterns that eerily mirror biological rhythms. These aren't just magnetic glitches. Their behavior, they evolve, they pulse, they react. Some scientists have quietly begun to suggest that Neptune's magnetic field might not be generated by a typical metallic or conductive fluid core at all. Instead, the data points to exotic superionic ices, a state of matter where water behaves as both a solid and a liquid, conducting electricity like molten metal, but structured like a crystalline mesh. These materials, under Neptune's crushing pressure, might flow in chaotic belts, driving internal storms, turbulence, and a magnetic map that redraws itself in real time. But even this theory doesn't explain why the field reacts to solar events before they happen. Unless Neptune isn't just reacting, it's predicting. Here's where things spiral into the truly unexplainable. Neptune is cold. It should be cold. It's 30 times farther from the Sun than Earth. But James Webb's thermal imaging found something impossible. Deep within the atmosphere, hidden beneath clouds of methane and ammonia, lie warm patches, pockets of heat, localized, persistent, and growing. There are no large moons causing tidal heating. No solar radiation penetrating that deep, no geological activity that we know of. And yet, Neptune is burning from the inside out. Some theorists now believe that Neptune may host internal thermal pulses, rogue waves of energy migrating through its structure, perhaps even initiating its hurricane-like storms. But what causes them remains a mystery. One hypothesis barely whispered among astrophysicists is that these pulses are the result of phase transitions in the superionic material, matter flipping between states, releasing bursts of energy. If true, then Neptune isn't just reacting to physics. It's generating its own rules. A planet not in equilibrium, but in controlled chaos. Then came the data that stopped the world. From the heart of Neptune, buried in the static of radio emissions, scientists detected an irregular signal, not noise, not atmospheric interference, a low-frequency pulse with spectral characteristics that didn't match anything observed in natural planetary systems. It repeated. It oscillated and then it vanished. But not before it had been recorded by at least 3 independent observatories. The scientific community was divided. Was it a product of the exotic magnetic field? A resonance caused by Neptune's strange internal chemistry, or was it something else, something more intentional? Some even pointed to the possibility that Neptune's structure, if it does include stratified cavities or pressure-bending pockets, might function like a resonant chamber, a natural amplifier, a signal booster, or worse, a transmitter. The idea that Neptune might be emitting a signal not as a side effect of physics but as part of its architecture shattered conventional models because a planet that resonates like that intentionally or not might be more than a planetary body. It might be a mechanism. Neptune has always been home to one of the most violent storms in the solar system. The Great Dark Spot, a vortex the size of Earth. But now, James Webb's near-infrared imaging revealed something that no one expected. The storm isn't just persistent. It's growing smarter. It adapts. It shifts direction in response to solar wind patterns days before they arrive. Its temperature fluctuates in harmonics, and its outer bands appear to exchange mass with nearby clouds at frequencies that resemble biological respiration. One model even showed that the storm's core aligned momentarily with the shifting magnetic field, as if it were coordinated, as if this wasn't weather anymore, but behavior. If Earth's hurricanes behaved like this, meteorologists would consider it sentient. So, the question arises, what happens when a storm is no longer just weather, but a function of something deeper? As Webb continued observing Neptune's atmospheric dynamics, a shocking geometric pattern began to emerge. At first, it was dismissed as data artifacts. But after weeks of comparison with past observations, it became undeniable. The distribution of Neptune's thermal pulses, the rotational timing of its magnetic anomalies, and the orbital paths of its inner rings, all aligned with what mathematicians call a quasi-twoidal symmetry. This isn't common. It's not random. It's the kind of structure found in engineered systems, particle accelerators, energy containment fields, even some theories of propulsion. The problem, Neptune isn't a machine, or at least it's not supposed to be. And yet, the more the data is analyzed, the more this pattern emerges, hinting that Neptune may be hiding an internal architecture, one that interacts with gravitational forces in ways that allow it to regulate its own orbit, its own chaos. And that begs a disturbing possibility. Was Neptune shaped by nature